You know, it feels like every single week there's a new AI model that's breaking some kind of record. But what if I told you the real breakthrough, the one that actually matters, isn't about making AI bigger, but about making it trustworthy? Hello to all viewers of my channel. Now, just take a look at this. This comes from a recent study. One AI hit 86% accuracy on a medical diagnosis. Another, the famous GPT-4o, only managed 25%. In a cancer diagnosis, that's not just a gap, that's a life or death chasm. So my question is, how on earth can one AI be so much more accurate than another? And what does this tell us about where AI is really headed? So where did that crazy number come from? Well, it was from this really fascinating and frankly, super high-stakes experiment. Researchers gave a bunch of different AI models a really critical job. Look at CT scan findings from 100 fake patient files and figure out the exact stage of their lung cancer. I mean, this is a task where you need absolute precision, the latest knowledge, and there is just zero room for mistakes. Okay, so in one corner, you've got this AI called NotebookLM. They gave it the official Japanese lung cancer staging guidelines to work with. And get this, it correctly staged the cancer in 86 out of 100 cases. That's a pretty remarkable level of accuracy. And then, in the other corner, you have one of the heavy hitters, right? GPT-4o, one of the most powerful general AIs out there. When it used its own massive knowledge from the internet, its accuracy was a shocking 25%. Yeah, just 25%. But wait, the story gets even more interesting when you start peeling back the layers. All right, take a look at this chart because it really breaks it all down. Over on the left, that's NotebookLM, sitting pretty at 86%. On the far right, that's GPT-4o, just doing its own thing, down at 25%. But the real shocker? It's that middle bar. Researchers gave GPT-4o the exact same expert guidelines. They call it reliable external knowledge, or REC, and its accuracy only crawled up to 39%. This is huge. It proves that just having the right information isn't the whole story. What really matters is how the AI is built to use that information. Okay, so what is going on here? Why this massive, massive gap in performance? Well, it gets us to a really fundamental problem with most of these big AI models. It's a flaw that makes them, frankly, pretty risky for any job where the stakes are high. We're talking medicine, law, engineering, you name it. The problem has a name you've probably heard before: hallucination. This is what happens when an AI, which has been trained on the wild, chaotic, and often totally outdated mess of the internet, spits out an answer that sounds totally confident and believable, but it's just plain wrong. It might mix up a few details, pull up an old rule, or literally just make something up to fill in the blanks. And in a hospital? Yeah, that's incredibly dangerous. You know, one expert came up with what I think is the perfect way to think about this. A general-purpose AI can be like a smart, drunk intern. It's brilliant, sure, it can process tons of info, but it's drunk because you never, ever know when it's going to make a completely random, unforced mistake. You have to be constantly looking over its shoulder, double-checking everything. So, how do you sober up the intern? Well, the solution is a totally different way of thinking about AI. It's an approach that's specifically designed to get rid of these hallucinations. It's called grounding. And the way it works is by completely changing where the AI is allowed to get its answers from. This slide just perfectly lays out the difference. On the left, you've got your typical large language model. It's living in an open world, pulling answers from its gigantic training data, basically the internet. But on the right, you have a grounded model like NotebookLM. It operates in a closed world. It is strictly, and I mean strictly, forbidden from using any outside knowledge. It can only use the specific, trusted documents that you give it. That's it. The tech behind all of this is called Retrieval Augmented Generation, or RAG for short. Now, that sounds super fancy, but it's actually a pretty simple and powerful idea. Before the AI even tries to answer your question, it first has to go find, or retrieve, the most relevant parts from your documents. Then it uses that information, and only that information, to build its answer. And the best part? It even gives you citations. It is literally forced to show its work. And here's what that actually looks like. This is the NotebookLM interface. See that panel? That's where you build your closed world of facts. You can upload PDFs, text files, Google Docs. You can even link to websites or YouTube videos you trust. This becomes the AI's entire universe of knowledge for whatever you're working on. Let's make this real with an example straight from the study. In one of the cases, case 2, the correct diagnosis was T2
N2M1B. NotebookLM absolutely nailed it, and it even cited the exact rules from the guidelines that led it to that conclusion. Now look at GPT-4o. When it was just left to its own devices, it got every single part wrong: the T, the N, and the M values. That's not a little mistake. That is a completely different diagnosis with completely different and very serious consequences.
Okay, so it's pretty clear this technology is a massive game changer for, say, a radiologist. But what about the rest of us? What does it mean for you and me? Well, the really exciting part is that this whole grounded AI thing isn't just stuck in a research lab. It's a tool that anyone can start using, like, right now. I mean, just think about it. Imagine uploading all your research papers and suddenly having a personal, searchable library. Or you could feed it a really dense book and instantly get a summary or a study guide or even a quiz to test yourself. You can even ask it to create things like mind maps to visualize how different ideas connect across all the sources you've given it. It's basically like having a research assistant who has perfectly memorized only the stuff you told it to care about. And for anyone who's curious, there is a free version and there's also a paid plus plan. The main things you get with the paid plan are way higher limits on how many sources you can upload and how many questions you can ask. You also get the ability to collaborate with other people in shared notebooks, and it comes with better security features, which is obviously a big deal for teams and companies. Okay, now as amazing as all this sounds, we have to be realistic. It's really, really important to understand that this technology is still a work in progress. It's a huge step forward in making AI reliable, for sure, but it is not perfect. And it's not foolproof. In one of the cases, case 50, NotebookLM actually made a mistake. There was a tumor that measured 4.2 centimeters. The AI found the correct rule for classifying tumors based on size, but then it made a simple math error. It concluded that 4.2 is less than 3. This just goes to show a known weakness in a lot of AI models. They can still struggle with precise numbers and reasoning. So here's the bottom line. While this grounding approach does a fantastic job of solving the hallucination problem, there are still other hurdles to clear. Like we just saw, that numerical reasoning thing, it definitely needs to get better. And before we see this widely used in super sensitive fields like medicine, there are major challenges with data security and patient privacy that have to be figured out. That probably means we'll need systems that can run completely offline without sending any sensitive info over the internet. But make no mistake, this technology is here right now, and it's already incredibly powerful. What it really represents is a shift, a move away from AIs that try to know everything and toward AIs that can become a perfect, reliable expert in your specific world of knowledge. So I'll just leave you with this thought to chew on. What happens when every expert, every researcher, every doctor, every lawyer has their own personal AI assistant, grounded only in the sources that they trust the most? Subscribe to the channel and like, and also suggest your topics for future videos in the comments.